This is linear motion practice C number 1. A car with an initial speed of 6.58 meters per second accelerates at a uniform rate 0.92 meters per second squared for 3.6 seconds. Find the final speed and the displacement of the car during this time. So we have two unknowns in this case. We're going to start with our problem solving method, write down and identify the given values, implied values, and an unknown target, check the units, and then pick out an equation to use, or in this case we might need two different equations of motion. Okay, so let's write it down. Initial speed or initial velocity is the same thing, that's a given. There it is. It accelerates at a uniform rate of, 0.92 meters per second squared for 3.6 s, that's seconds. So we're talking about a time there. I like writing SEC because my S's look like 5s. There we go. Means seconds. Find the final speed or the final velocity, it's one unknown, and the displacement, that's x. Where is it going to be? How far will it have traveled? So we're looking for two unknowns. In this case, I can put away the text, so I don't really need that anymore. And let's look up our equation here. So given the values there below, which one can we use for VF? Should we use the first one here? Should we use this one? VF equals VO plus AT. Well, if we look at it, we've got VF is the unknown. We've got V0, VO. We've got A, and we have T. So sure, we can use that one. How about for X? Should we use the third one or the second equation here? If we look at the third equation, we don't have the final velocity yet, but we do have the other values. And we could use some algebra to find that X value. But how about the second equation? X equals initial velocity, we got that. Time, we got that. Acceleration and time, and we have both of those two. So we can use the first equation to figure out the final velocity, and the second equation figure out the displacement, the x. So I'm going to go ahead and write those down just one at a time here. VF equals V0 plus AT, and x equals V0t plus 1/2 AT squared. Get in the habit of writing them down because this makes this next step super easy. Final velocity, our unknown, is 6.58 plus acceleration times time. Time is 3.6. Get out the calculator, turn my face off, and the calculator on. There we go. So I'm going to start out with the 0.92 times 3.6. If you've got a more scientific calculator or graphing calculator, this is a whole lot easier. You can do this in one step. I'm going to add the 6.58 to it. 9.89. I'm leaving it with 3 significant figures because I plugged in 3 here and 2 there, so we'll keep it as 3. And 9.89 watt. The watt is what value is 9.89? Well, it's a velocity, and our velocity units are meters per second. We've got all meters per second and seconds, so this will also be in meters per second. There's one of the unknowns. We go on to the next one. X equals initial velocity times time, 3.6 seconds, plus half of the acceleration times time squared. There it is. And we solve that one. All right. We'll take that 6.58 times 3.6 is 23.688. I'll go ahead and keep those units, or those decimals for now. Plus, all right, now we're going to have a 1/2 of 0.92. Then we got a 3.6 squared. I'll just multiply that by 3.6 twice. We got a 5.6 9616. I'm going to add that to the 23.688. So our displacement, keep the 3 sig figs again, is 29.6 meters. There it is. We'll check the rest of our problem solving text. We solve for the unknown. Are these reasonable? They're not hundreds of meters per second, and they're not like inching along. So I think this is it. We're done.